Okay. Castellucci?
Castellucci.
Let me introduce Ryan Castellucci, who's our speaker for this morning. And he is the principal security researcher at White Ops.
White Ops.
And he got to White Ops simply because of running into Dan Comiskey on Hackers on a Plane. And years later, Dan saying, you know, come work for me. And he's doing some pretty interesting work. Today's talk is a nickel tour of the ad fraud ecosystem. And I hope you enjoy it. Please welcome the speaker.
Good morning, everyone. How are the hangovers? I'm Ryan. I've been working on bot detection at White Ops for about 3 years now. So since the late 90s, the web has been running largely on ad money. Can I get a show of hands? How many of you have at least thought, if someone clicks ads on my site, I get money. I can automate that. Yeah, so early on, it was really, really easy to get away with that. The thing is, if you're like doing banking Trojans to steal people's money, you've got to get the money out, and you're pissing off banks, which have a bunch of people with the ears of law enforcement. Advertisers, or the advertising industry, the perception of fraud is bad for business, so until recently, they kept it fairly quiet, and there was an arms race going on. They would improve their ability to detect fraud, and the fraudsters would get better at it. And when they got caught, mostly they just got banned and had to make a new shell company. Anyway, I would like to share with you what I've learned about the advertising industry and the state of the art in both bots and bot detection. And for the purposes of this talk, just so we're clear, bot refers to an automated HTTP client. Detection techniques include both passive analysis of requests and active analysis via client-side JavaScript. So you might think that trying to write code that defeats an adversary by running in an environment they control is kind of a lost cause, like DRM, but it's not actually the case. Before I get into that, I've got background information to go over. So the ad tech industry has lots of jargon. Go over some of the major ones. A placement is a location for an ad in the context of an individual page view. A creative is what they call the ad content, which can include arbitrary HTML, JavaScript, images, videos, whatever. It gets stuffed in an iframe somewhere. Generally, these things are scanned before being approved to run to ensure they're not malicious and comply with industry standards. But we all know how well virus scanning works. Verification is about what it sounds like, though there are a bunch of different types of verification. I'll get into that a little more later. So the pipeline of systems from the advertiser to your ad blocker is actually quite complex and is broadly known as ad tech. We're going to focus on programmatic advertising, which is the majority of digital ads these days. There are a whole bunch of different types of companies involved in this. For any given type of company, there's probably a couple dozen companies doing it. I'm going to kind of have to simplify this a little bit in the interest of time. Of course, the most important kinds of companies in this industry are the advertisers. They're very important because they have money. They vary widely both in their technical sophistication and how much they spend. Usually the technical and artistic components of advertising campaigns are outsourced, but some of the larger advertisers handle that internally. An advertiser will work with a media agency. They give the media agency a budget, establish goals for the campaign, and then let them handle the details of running it. The media agencies will pick what vendors to use for tracking and verification services, which DSPs to buy placements through, and so forth. They usually get paid hourly fees for consulting and then a percentage of the money the advertiser spends. So demand-side platforms, we're getting into things that, what the hell is this? They allow a company to place orders for the placements they'd like to buy. with quite a lot of detail. This can include what sites they would like to run their ads on, either categorically, like news sites, or specifically, like the Washington Post, consumer demographics, regions, and so forth, and what price they're willing to pay. Someone could, for example, run a campaign on news sites targeting people who live in the Northeast, own a dog, and are in the market for a new car. More ominously, I've seen some DSPs that allow targeting that I think is a little sketchy. They'll let you target very, very specific browser and operating system versions and IP ranges. So using one of these things, you could say target out-of-date web browsers running on IP addresses assigned to congressional offices. Anyway, all of this data goes into the DSP's real-time bidding system. And the DSP gets paid a percentage of money spent and sometimes a subscription fee for use of that technology. Supply-side platforms aggregate multiple publishers and help them sell placements. This is necessary because there are a lot of websites out there, and nobody wants to make individual deals with every website. So when a page is loaded, the SSP code will talk to the DSP servers through the real-time bidding system and pick one of the DSPs to sell the placement to. They'll work with tracking vendors to be able to provide more demographics to buyers, which increases the value of the traffic. And then they'll use verification vendors to decrease the risk of selling fraudulent traffic, or at least have somebody to blame if they do. The verification vendors can also act as impartial third parties to mediate disputes about traffic quality. And they get paid, the SSP gets paid a percentage of money spent. Next we have publishers. Publishers run websites. Some of them are user-generated content sites that revenue share with content creators. Some of them are sites that produce their own content. The bigger ones pre-sell traffic directly to DSPs, media agencies, or advertisers. Now, if they pre-sell too much traffic, they've got to make up the slack somehow. And this is frequently done by buying traffic. And when they're buying traffic, they're going to get the cheapest traffic they can get away with. So this ranges to just straight up bots to being made featured content in the other things you might like section of other websites. And they'll work with tracking and verification vendors basically for the same reason SSPs do. And they usually end up with the biggest share of the advertiser's money. Content creators. The best example I can think of for this is YouTubers. So they produce content, they're hosted on some platform, and they get a revenue share. So they'll get a cut for revenue with ads, from ads presented with their content, which is a direct incentive to boost their numbers, but they also have indirect incentives. If they're getting a lot of traffic, all of a sudden they might be featured as popular or trending, which will get them actual human subscribers. So that can be great for them as long as they don't get caught. If the publisher thinks they're doing something funny, the publisher generally can just cut them off with no recourse, and they get paid what the publisher says they're owed. Real-time bidding is high-frequency trading for ads. So this is, an ad will be, when the ad tries to load, the request will be held for a few tens of milliseconds until a decision has come back from the system and a DSP, an advertiser, have been chosen. So it'll make a request, kind of hang there for a while until it's found the highest bidder. The data sent to DSPs can vary. Generally, it's going to include IP address, user agent string, refer, domain, possibly full URL. If it's mobile, it'll be the name of the app or the app ID. Geolocation data will be in there. Demographics will be in there if they have them, and the size of the placement will be in there. So verification, tracking, and measurement companies are called from an ad usually by either a one-by-one image tag. Nowadays, these are called pixels. We used to call them web bugs, or JavaScript. So I work at White Ops. We're a verification vendor. We focus mainly on fraud detection, though we supplement that with brand safety and viewability services because a lot of clients want to limit the number of providers they use. Brand safety, really simple. Most advertisers don't want their ads to run on porn sites or piracy sites. Viewability has historically been done as a ridiculous collection of browser-specific hacks and weird shit with Flash. There's a new API from W3C called Intersection Observer, which lets you simply ask the browser, hey, is this element visible? Useful. So it's supposed to fix this, but not all browsers have it yet. And then measurement. So it turns out that if you have two different companies counting how much traffic an ad is getting, they'll probably manage to come up with 3 or 4 numbers between them. And if they can't agree ahead of time on whose count's going to be canonical, they can just hire a third-party measurement company to do this for them. So the ad tech ecosystem is extremely complex, so it shouldn't be surprising that there are lots of ways to defraud it. The simplest ways involve creating some content, either on a site with revenue sharing or a dedicated site, and then buying some traffic. Sellers of traffic vary a lot in how upfront they are about what exactly they're spending or selling. Some of them will offer real, organic, unique users, and some of them will say, we'll give you clicks. So in the former case, the buyers have some plausible deniability. Some of them might even believe it, and are genuinely trying to build a real audience. And then there's sites that are like not designed for human traffic at all. They're just designed to be a way to cash out bot traffic. These are called ghost sites, usually, kind of in reference to ghost towns where you have a city with no people in it. They're often disguised as low-quality blogs or video sites, though we've also seen ones that are just literally a grid of ads for the full page and nothing else. So the next trick is to be an SSP, generate inventory, and sell it to DSPs. And this is a way that large-scale ad injection campaigns monetize. So like stuff like ad injecting malware, DNS changer, shady VPN proxy, and Wi-Fi providers that inject ads. This is basically how they have to work because they're showing up as multiple different publishers. We've also started seeing what I call vertically integrated bots, which combine both the traffic aspect and the inventory aspects of this. The MethBot operation that I recently spent a bunch of time analyzing was a good example of this. So I mentioned that buying bot traffic can help someone make a profit. There are, of course, people who sell this. So these bots either run directly on compromised end-user systems on a traditional botnet, or what we call a bot farm, which is a bunch of servers running bots. A bot farm, at any scale, will need some IP diversity to avoid trivial detection via data center blacklists. Usually they handle this through proxies, either open proxies or proxies running on a botnet. So next we have we call traffic laundering. So sites with real user traffic but unsavory content, again, torrent sites, pirate video streaming sites, porn sites, they can either build their own clean site or work with one and simply stick that site in an invisible iframe somewhere or frame it so the ad actually displays if somebody's checking viewability. So a cursory check of where the ad is running will show the clean site rather than the unsavory one. Next we have ad stacking. So you've all, I'm sure, had the experience of searching for something on Google or whatever, and there's just a bunch of crap there. It's SEO spam. So they'll get clicks, but the people who visit those sites frequently won't stay very long, and there's not a huge amount of traffic. So they want to pad their revenue, and a way to do that is ad stacking, where you'll either simply place you'll place multiple ads in the same spot on the page, just stacked on top of each other, or have some invisible ads. Another option is called cookie stuffing. If anyone's familiar with affiliate marketing, the idea is you've got some content, you convince people to go to the merchant site sets a cookie in their browser, and then if they buy something from there in the next couple of days, you'll get a cut of the sale. But getting people to click on links is hard, so you can just iframe the affiliate links, and the cookies will get set. All right, so let's talk about bot designs. The stupidest thing that could possibly work. Curl and wget in a shell script. Yes, this happens. The idea is you figure out what exactly the URL that will get you paid is, and you hammer it from your Internet of Things botnet. This is trivial for anyone who cares to catch. Next up, we have scripts in high-level programming languages: Python, PHP, Node, Perl, Ruby, whatever. Basic scraper, crawler code. These things parse HTML, which makes them a little smarter than a shell script, but they don't run JavaScript, so they're still pretty easy to catch. Next up, we have off-the-shelf headless browsers. Phantom.js is probably the most popular one of these. They're tools designed to automate interactions with pages that require JavaScript execution and don't display anything. Usually, they're used for scraping or to automate QA of sites. These are pretty easy to detect if you know what to look for, because they're designed for legitimate purposes. They're not designed to be stealthy. But many of the simpler ways to detect them can be fooled with a little bit of modification. Then we have embedded browsers. Most major browser engines can be embedded inside other applications to display HTML content. IE's web browser control, Chromium embedded framework, and WebKit are popular options. Mozilla used to have an official embedded Gecko thing, but they dropped support for it a few years ago, though it's still possible to make it work with modern versions of Geckos. It's just a pain in the butt. These tools are usually intended for the display of trusted content, and so they sometimes have a bunch of security precautions disabled. Also, with the exception of IE, keeping them up to date is a pain because you have to ship new code every time there's an update to your engine. Adware likes to use these things. So the other thing is it's common to make applications available to API within the embedded browser, and those APIs are not always safe. These can be widely varied in how hard it is to detect them, but it really depends on how much customization has been done. And there's automation tools. Selenium uses a protocol called WebDriver to talk with browsers, and it will use a real browser. Possibly, some of them have native support for WebDriver, some of them require a plugin, but it allows the browser to be programmatically driven. These are also designed for QA automation and scraping. But they actually display the browser window, so it's a little bit harder to use them on a bunch of compromised end-user systems. There are also not just tools for using these with desktop browsers. There's mobile browser ones as well. WebDriver is, I believe, still in draft spec, and it says that anything running WebDriver is supposed to expose itself by setting WebDriver equals true on the navigator object in JavaScript, but not all of them currently implement this. And even if they did, they could be overridden. And these are pretty hard to detect since they are real web browsers. Next, we have system emulators. So these are popular for generating mobile traffic, because otherwise you're stuck with a shelf full of mobile phones, which also happens, but it just is annoying. This can also work for desktop traffic, but the idea is you run your bot inside the emulator or virtualization tool, automate it with Selenium. You can do this in a botnet, but it needs a lot of memory, so it's more popular to do it on bot farms and then run the traffic through certain proxies. This is actually easier to detect than just using the automation tools alone because of VM or emulator weirdness. Finally, you could build a browser from scratch to run ad fraud through. This is a lot of work, even if you're only selectively implementing browser APIs that are required to make verification vendor code happy. It's not just the initial work either. These days, both Chrome and Firefox are now what we call evergreen browsers, so they're releasing every 4 to 6 weeks a new browser that has new APIs in it. So if you've got your custom browser engine for your bot, you have to do maintenance work on it to keep it up to date with features that are being released as verification vendors start checking for them. But the advantage is that you get a really deep level of behavioral control so that you can run one bot that is able to somewhat convincingly masquerade as multiple popular web browsers. Didn't actually expect to ever see this because it just seems like way too much trouble, but we recently found one called Methbot. Methbot, we got some press coverage for this, I think late December. We originally found this thing in 2015. It was sending a cache control header with invalid data in it. And at the time, it wasn't sending us back anything from our client-side JavaScript code, so we figured it was just a primitive script and added a check for the bad header data and moved on with our lives. It turns out we were wrong about that, though. It looks like it was, from what we know now, I think it was just failing to run our code due to some quirk in their implementation. So this September, they finally fixed the cache control header and whatever was breaking our code. And we started getting traffic back from them. And then our ops people freaked out. This thing was a little bit buggy, and we were getting a ton of errors for invalid HTTP methods. And I got roped into troubleshooting this and down the rabbit hole. So HTTP has support for something called pipelining, which is where you send multiple requests down the same TCP connection. This depends on a field called content length, identifying where one request ends and the next begins. But their code for generating the content length headers sent the number of characters in the data they were sending rather than the number of bytes. If anyone's worked with UTF-8, you will know that these are not the same numbers if there's anything other than plain ASCII. So one post would end, and according to the content length header, the ending was before the actual ending, so you'd get a bunch of garbage, and that would be interpreted as the start of a new request. So our estimates on this thing were that it had 830,000 IP addresses. We have a list across about 1,000 dedicated servers, able to do hundreds of millions of video ad impressions per day. They spoofed popular sites to get premium rates on this, millions of dollars per day, and we got a pretty good picture of the internals. All of this infrastructure allowed a somewhat interesting mode of operation. Rather than creating cache-out sites, the guys behind Methbot appear to have set themselves up as an SSP. They would generate a page internally, blank except for a video player, and then run an ad inside of it. Because they had a custom browser engine and HTTP library, they could make the domain information from JavaScript and the referrer header say whatever they wanted. And they had lots of control over what verification vendor code got. And hold on. So this operation depended on a bunch of painstakingly acquired IP space. So we published it. Their BGP announcement stopped within about 24 hours of the release of their IPs. And most of them have been offline since. I haven't checked them all again recently, but anyway, so this is how they were running third-party JavaScript. This is from Node.js's VM module. This is essentially eval. The difference is rather than executing in global scope, it allows a new global context object to be passed in along with the code, and it allows for timeout of the code, even if it's doing asynchronous stuff. And if you can run code in JavaScript, JavaScript has a bunch of reflection features which allow for things like enumerating variables, objects, and functions, and you can even dump formatted source code of functions with the comments. So this bot written in JavaScript is basically evaling our code. Okay, so I used to do a lot of Perl when I was younger. I got better. Seriously, though, JavaScript has a global object which contains all of the global variables. In a browser, this is called window. In Node, it's been creatively renamed to global. So you can dump out a list of variables under this object by calling the object.keys function on it. And if you just select random things out of this, if there's high enough traffic volume, eventually you get everything. And another important thing about JavaScript is it allows the environment to be monkey patched. You can override built-in functions very, very easily. So normally the toString method on a function will give its source, but you can redefine the method. To get around this, we make a new function, grab its toString method, and apply it to the target function. With the way JavaScript works, it's object-oriented, so if you've worked in object-oriented programming languages, you'll be familiar with like a cell for this object, which is what the first argument to apply does in JavaScript. So it's not passing an argument to that function directly. It's saying, hey function, this is the object you are on. So this works especially well. The toString stuff works especially well on a bot written mainly in JavaScript. But with many other bot designs, the easiest way to do spoofing of the JavaScript environment is just to inject a script into every page. So it's generally useful. So the authors of MethBot tried to patch our code before running it. This is kind of clever, but didn't fully work. So here's what they were patching in. If you don't know JavaScript, what this does is basically just re-implements the default behavior of toString, except for that it eats exceptions. And this can be detected by calling toString on the toString function, yodog. This is basically the same thing, except for patching toString for arbitrary objects. This is special for functions. Another fun thing they did was blocking our Flash. I guess they decided they couldn't or didn't want to be bothered to spoof the necessary data from Flash, so they just blocked the file. But this is a statistical anomaly because then all of a sudden we have all of this traffic that for some reason isn't running our Flash code. The other thing I'd like to note here is it looks like at one point, by the time we saw it, they had disabled this, but I guess for development or something, they made a copy of our code and we're serving it internally from the bot to try to see if they could subvert it that way or something. I'm not really sure. They also made lots of typos in their code. Mozilla is supposed to be spelled with one Z and two L's. And this wasn't a mistake in one spot. I think I found that misspelling in at least 4 places. And then the other fun one was, well, it's really popular for trying to detect bots to enumerate the plugins list, and they accidentally stuck a space after the .dll in the name of their Flash plugin. As I mentioned earlier, this thing had a bunch of IP addresses. I'm sorry for people in the back who can't read this. My slide, I will have a link to my slides at the end, and I'll get them uploaded in an hour or two. This is a range of IP addresses that claims to be owned by Comcast, and it's registered through Afrinic by someone using an email address of adword.yandex.ru@gmail.com. That's adword with a 0. As much fun as it is to pick on Comcast, they did this with pretty much every American major ISP. Okay, so this particular group of IP addresses, all of these ones I just showed you are delegated from a company in South Africa called Link Data Group. Link Data Group's website shows a directory index with CGI bin listed, and their domain was registered around the same time these allocations were set up. Yeah. Last year at a NANOG conference, Leslie Noble from Aaron gave a presentation where she mentioned that criminals have been forging documents and setting up shell companies to take over IP address space allocated to defunct companies. The ones she mentioned had all been trying to do this to sell the IP address space, but it looks like maybe these folks found something more profitable to do than selling the IP space. I should also note 800,000 IP addresses at current market rates are worth about $6 million. Here's another one. This one is out of RIPE rather than Afrinic, and there's a couple things I'd like to note about this. One, if you look up these IPs now, the data has changed. Another is that this delegation is from a Russian steel foundry, which appears to be a real company. I guess they're doing something with their IP addresses on the side because they have a /15 that they got allocated in the 90s. The phone number here is invalid. Any of you freaks will know why the number after the area code can't start with a 1, as it does here. And then if you Google for NetBcom LLC, the only hits you'll get are copies of the Whois data for this IP range. Okay, so some other JavaScript dumping countermeasures that are a little bit more generic. This is one I found in the wild. I'm not sure what this software is, but it's a little bit more clever than what Methbot did. They were running this on, they had monkey patched the alerts and dialog functions so that if those got called, it wouldn't block. So this still failed. Here's how I would do it. This one works by patching the default toString function that's used if a custom one isn't defined. So if you, and then it checks to see if the function being called is called toString, and if it is, it gives the result that the default that you would get running toString on the default toString function. Everybody with me there? So this is much harder to detect. There are still ways to find it. So bot detection. The simplest way to detect bots is with blacklists. IP addresses, user agent strings, app IDs, domain names are all common things to have blacklists for. This is great for filtering out bots with no intent to defraud, such as search engine spiders, and prevents a lot of dumb things from working. But it's not entirely robust. As far as the user agents go, there's an industry standard list from the Internet Advertising Bureau called the Spiders and Bots list, which is actually a combination of a whitelist and a blacklist with a bunch of processing flags and exceptions. It's kind of tedious to implement. I wrote something to handle this in Groovy, which I will be putting up on GitHub this week. My favorite way to detect bots is just to do consistency checks. So there are dozens, maybe even hundreds of behaviors that vary between different OSs and browsers. And if you look at a bunch of them, you can see whether or not they tell the same story. If a bot is trying to pretend to be something it's not, it has to lie. And if it doesn't keep all of its lies consistent, you know something's up. The other fun thing is statistical anomaly detection. So you have the makeup of organic traffic, and then you have the makeup of bot traffic. So you'll see weird distributions of browsers and operating systems. For example, you might see only IE on a particular domain, or it could be all Chrome, or there might be no Safari at all, or the versions might be old. With Methbot pretended to be Chrome on Windows 10 and Mac OS X and nothing else. A little later, they added some more stuff, but it was way skewed. Other stuff you'll see, you'll get lots and lots of traffic from a few IP addresses, odd timing of traffic patterns. So like if a particular IP is giving you traffic at a very, very consistent rate 24 hours a day, 7 days a week, that's a bot. If it spends too much or too little time on sites, it's a bot. If the distribution of times doesn't follow a bell curve, probably. Bots might never skip video ads, or every single time they'll click on the page or scroll it. That sort of stuff. Just doesn't look right. And then if you're a tracking vendor, you can look for suspicious users who visit too many different sites, or too few sites, or really weird combinations of sites. And then there's detections for specific bots and tools. I can't give away too much secret sauce here, so these are some well-known or obvious ones, or work on bots that are no longer around. So the W3C WebDriver spec, Navigator WebDriver is true. On Firefox on WebDriver, it sets a WebDriver attribute on the main HTML element for the page, which you can pull for. Phantom sets some global variables. Lots of bots override functions like alert or console.log. We found one a while ago. It's disappeared now, but it was setting a header called content support with 1p. And then Methbot, of course, the cache control value used colon where it should have used equal sign. You can also look for security controls being disabled. Flash is lots of fun. I shed a little bit of a tear for the fact that major browser vendors are killing it, and it's frequently forgotten by ads now. I mean, overall, Flash going away is great, but it had some fun tricks. One of my favorite things was the OS field under capabilities. So if you've ever looked at user agent strings, you'll know that for a particular version of Windows, you'll see something like Windows NT 6.2. And that can refer both to a desktop version of Windows or a server version of Windows. Flash, on the other hand, will tell you things like, oh, this is Windows 2000 or Windows Server 2008 R2, which you don't get from the user agent string. And then on Linux, if you were using the old Netscape plugin API version of Flash, usually with Firefox, it would actually give you the kernel version, the full kernel version. So that was fun. There's a bunch of other weird stuff in that capability string too, like pixel aspect ratio, screen resolution, which you can compare against the JavaScript screen resolution, whether or not MP3s are supported. It's weird stuff. If you want to look for VMs, you can check. Well, you can use Flash to see whether something is actually being drawn on the screen. If it's not being drawn on screen, there's render throttle events it generates. You can also check whether or not hardware video acceleration, both 2D and 3D, are available in VMs that usually won't be. You can get lists of the microphone and camera devices, which are usually going to be blank in a VM. And that's about it. So does anybody have any questions? Really? No questions? Oh, there's one.
I was curious about what your main question
Oh, so we partner with a bunch of companies in the industry, and oh, sorry, he's asking how we're able to get this data, how our code's able to run. So we work with a bunch of companies in the industry. They'll include a reference to our JavaScript code alongside the ads that they run. So when the ad loads, our JavaScript also gets called, and we can have a look at the environment. Next question. So the question is, how does ad blocking affect bot detection? Well, a bot is trying to view ads, so it's not going to run an ad blocker. So this isn't really something we're particularly concerned about. It could possibly cause false positives, but even if it does cause a false positive, the advertiser wants to know if the ad has run, and an ad blocker is not going to run the ad. So if it's detected as a bot, it doesn't bother anyone. Next question. Do we know how long Methbot was running? Not exactly. We know it was running since sometime in 2015, though in the form it was in when we found it, we're pretty sure we found it pretty much immediately when they updated the code. So that happened in September, and then we shut it down in December. Next question.
So it seems like you found this because of mostly some typos and some, like ad phone numbers and stuff that, just basically knowing the United States better and not being trapped people trying to solve things wouldn't have been an issue. So would you have been able to detect this, assume that they did everything right and looked all legit? How much harder would it have been to track this down?
So the question is basically, how much harder would it be to track this down if it did everything right? Doing everything right is really, really, really hard, and they just have to screw up one thing for us to notice. As far as like if they got the browser environment perfect, well, it probably would have broken when we did a code update. As I said, doing everything right would be very, very expensive. But yeah, if somebody did everything right, no, we're not going to detect it. But that's probably not going to happen. Next question. It's really, as I said, this thing, I'm not sure exactly how much of that number I quote. Oh, the question was about the economics of this. At what point is it worth it to try to get everything perfect? So I don't know exactly what portion of that millions of dollars per day ended up being revenue to the guys who wrote this thing, but I honestly don't know. It's really hard to get that information accurately, and I don't want to just make something up. I don't know how much exactly work it would take, but the problem is even if you get the environment perfect, you still have to deal with getting the IP space it runs on to look right, and unless your botnet is absolutely massive, the scale of how much you run is limited. It just doesn't look right if a single IP address is generating, if you have like many IP addresses all generating thousands of impressions per day, it just looks weird. So your scale is limited by the size of your botnet at that point. So yeah, I don't know. Next question. So the question is, what has been the advertising industry's reaction? There have been a bunch of press releases put out by various companies in the advertising ecosystem about how they weren't affected by MethBot. So lots of denial. It's mostly been positive, though. It's a lot of the ad tech industry kind of complains about lack of transparency from verification vendors. So it seems like a lot of people really appreciated that we put out a very clear report detailing how we found this thing and giving away all the IP space. Do we still have, I don't think we really have time for another question. Do we? Yeah, okay. I've got to go. If you have other questions, please try to find me later.